Let's see if you can remember. So most of you answered for A. So let's see if you are right. Here is the definition. So oxidation can be loss of electrons, loss of hydrogens, or addition of oxygen. And reduction can be gain of electrons, gain of hydrogen, or loss of oxygen. So now, why do you write, most of you? So, we are looking for the reduction. Reduction is a gain of electrons, right? So this is number 1, gain of electrons, and reduction is gain of hydrogen also. Gain of hydrogen or loss of oxygen. So, but we don't have the loss of oxygen. Loss of electrons is the oxidation. These two belongs to oxidation. So, the A is the correct answer. By looking at the structure of these two, which one is the oxidizing agent? Left one? Everybody agrees the left one is the oxidizing agent? Just from the definition, we have seen that the removal of hydrogen is the oxidation. Here, this one has the capacity to get rid of hydrogen from the substrate. So that's why it is an oxidizing agent, because it is helping to have the oxidation. So it is an oxidizing agent. And this one, then what it can do? This is the reducing agent, because look at that, it has a lot of hydrogen, and we know that the gain of hydrogen is the reduction. So each has the ability to give some hydrogen to the substrate. So it is a reducing agent. And we know that the oxidation reduction reaction just cannot happen. Just the oxidation alone cannot happen. If there is oxidation, there will be a reduction. And what happened that one? These two cycle, like the ADP and ATP molecule, these two also cycle between these two forms. They also cycle. So whenever we need the oxidizing agent, this one come, help to oxidize the molecule and convert this one converted to this form. And whenever we need the reducing agent, this one come, release the hydrogen and convert it to that form. So they can cycle all the time from one form to another form. Now look at their structure. Now we are going to see that what is that NAD plus thing? That the nicotinamide adenine dinucleotide. So nicotinamide is coming from, this is the nicotinamide, this portion. And we can see the dinucleotide is coming, this is adenine, this part, and there are two ribose units. That's why the dinucleotide name is coming. And why the NAD we write the plus form? NAD always contain a plus form, because here the nitrogen that contains a positive charge, that nicotinamide nitrogen, and that's why NAD we write the NAD plus, because it contains a overall positive charge. Which one is the reaction side? This nicotinamide is the reaction side. Here, this carbon that has the ability to accept hydrogen. And when it accepts hydrogen, here it happened like that way, and that charge disappeared. How that reaction happened? So now we need to recall our knowledge of hydrogen. Hydrogen, removal of hydrogen molecule is the reduction, or addition of the hydrogen molecule is the oxidation. So normally in the organic reaction you will see that the hydrogen is either it's losing hydrogen or gaining hydrogen. How many electrons in this hydrogen molecule? 2 electrons. So that hydrogen molecule equivalent to, can we just tell that if it breaks like equal way, that every atom, every hydrogen atom containing 1 electron, it can also break like this way, So both electron can go to one hydrogen and then give us H plus and 2 electrons on this hydrogen and the negative sign there. And we learned before, this one we call is the proton and this one we call is the hydride anion. So in the reduction, we learned before that this hydride ion is the important part because that is carrying an extra electron. That extra electron. So that extra electron, what if I draw that nicotinamide part? So that nicotinamide part. So here. So I'm just showing the hydrogen, that there is a hydrogen, so this nitrogen is the positive, and here is the rest of the part I'm not showing, because we don't see any change in the rest of the part. So what happened, this hydride anion with the 2 electrons, that can come to make a new bond with this carbon. And since this carbon is getting 2 electrons, so it can give away these 2 electrons, and then 2 electrons can come to form a new bond between those 2 carbons, and then finally these electrons can come onto the nitrogen. And as a result, the outcome that we are going to see that would form here is one extra hydrogen. So this one is the NAD plus, and this one is the NAD. How many hydrogen we have added in the NAD plus? Only one hydrogen. So that's why one hydrogen, NADH, is the part of the NAD molecule, and that is having one extra electron. Now the NAD plus, we don't have a positive charge, so that means it gains some electron. And what about the another hydrogen, this proton? That proton, because all the time we want to show that the equivalent of a hydrogen molecule is transferring, so that's why we write a slash and the proton like that. The proton is not part of the NADH, but the proton is in the solution. But that proton is always required for the reaction. That's why we write that proton with a slash to show that the proton is also part of the reaction. Make sense? So similarly, NADP plus and NADPHH plus, another coenzymes. What is the difference? They are exactly the same molecule, only difference in this highlighted hydroxy group. That hydroxy group would be another phosphate would be attached here. If another phosphate is attached, then we call it the NADP. So that is the nicotinamide adenine dinucleotide phosphate. That P is coming for that extra phosphate, this hydroxy group. There will be a phosphate group attached here. But the reaction mechanism is the same. Again, you can see that it has the ability to take an hydride anion. Another type of reduced coenzymes, or the coenzymes that we see that do the same type of thing, is the FAD or fat. So this is the structure of the FAD, and here is the reaction site. So a hydride anion can add it to this nitrogen, and the proton can add it to that nitrogen, and this is the new form of that. So that's why the FAD is written as the FADH2, because it is taking both of the hydrogen. So H2 here, part of the FAD. So these are the reduced, this is the reduced coenzyme, this is the coenzyme, and this is called the reduced coenzyme form. So they are always cycling throughout the metabolic process, depending on what type of reactions we need. And few important things that we need to remember regarding this coenzymes, that this form, like this form and this form, because they have extra electron. We can see that the hydride anion is bringing those extra electrons. Since they have extra electron, we call them the electron carriers. Because when they carry, so that means they are carrying the electron. So they are the electron carrier. We call them the electron carrier molecule. And we know that when the electron is transferring, some energy is also coming, some extra energy. This type of molecule also we call is the high energy molecule. So that means this is the blue form, less energy, and this is the high energy molecule, red form in your textbook. Like the ADP and ATP, ADP is the low energy molecule, ATP is the high energy molecule. Similarly, NAD plus is the low energy molecule, and NADH, H plus is the high energy molecule. So they can carry, they are the electron carrier, they are also energy carrier. So any questions so far from the this part?